Welcome to in my channel. In this video lecture I am talking on the topic cascade decomposition. At first, what is cascade decomposition? Anything which is connected in a series form is cascade. In case of cascade decomposition, the transfer function is in this form: y(s) by us equal to 1 by s plus 2 into 1 by s plus 3 into 1 by s plus 4. Means in function is in the factor form. For this transfer function, the output of the term 1 by s plus 2 is given to the input to 1 by s plus 3. Means this term is input for this term. 1 by s plus 2 is input for the 1 by s plus 3. Okay, and the output of the 1 by s plus 3 is given as input to the 1 by s plus 4. Means output of this 1 by s plus 3 is input to the 1 by s plus 4. Okay, and the output of the term 1 by s plus 4 is the system output. This is the block diagram of the given transfer function. The block diagram of this term is this one, and block diagram of 1 by s plus 4 is this one, and 1 by s plus 4 is this one. Okay, when we combine all this term, we get third order differential equation. Means here power of s is 3. When we change it into time domain, we get third order differential equation. Okay, now we let this term, for this term x1 dot equal to first order, for this term x2 dot equal to second order, for this term x3 dot equal to third order. Okay, because this is a third order difference, we get third order differential equation. That means 3 summing point and 3 integrating are present in the block diagram. Okay, when x3 dot is passing through integrator, it become x3. When x2 dot passing through integrator, it become x2. When x1 dot passing through integrator, it become x1. Okay, because 1 by s plus 2, here 2 is written, that means minus 2 is in the return path. Similarly for all those terms. From this block diagram we deduce state equations. Okay, at first consider this summing point. In this summing point we have to look what is the incoming are x2, this is the incoming, and this is also the incoming. Okay, so x1 dot equal to, when x1 is passing through this path and multiply with minus 4, it become minus 4 x1 plus x2. Okay, and x2 dot, look at in this summing point, what are the incomings? x3 and this one is incoming, means minus x3 2 plus x3. Okay, and looking at this summing point, what are the incoming is u, and this is the incoming. So x3 dot become minus 2x3 plus u. Okay, the output equation is y equal to x1. From these equations we find state model, because x1 dot x3 dot x2 dot x3 dot is here, so we written x1 dot x2 dot x3 dot, and the coefficient x1 dot equal to this equation. Means here x1 x2 x3 represent x, and this is the a A matrix, and this is B matrix and a U. Here coefficient of x1 and x2 is present, that means we written here -4 and 1, and coefficient of x3 is not there, that means here we written 0. Okay, when we come into x dot 2, means in this equation x2, coefficient of x2 and x3 is present and x1 is not present, that means here we written 0, and coefficient of x2 is -3 and coefficient of x3 is 1. Okay, now we move into x dot 3. X dot 3 equal to -2x2 2x3 plus u. Okay, that means only coefficient of x3 is present, that means x1, coefficient of x1 and x2 is 0 and x3 is written -2, and u is only with x dot 3, that means we written here 0 0 and 1, and the output is y equal to x1, and we have written here x1 x2 x3, and y equal to x1 means coefficient of x1 is 1 and coefficient of x2 and x3 is 0, that's why we have written here 1 0 0. Okay, thank you.